In this video, we'll be talking about how to write linear equations, most notably using point-slope form. So the ease of graphing, as we've seen, linear equations comes from the slope. Namely, if x1, y1 is a point on a line of slope m, and x comma y is any other point on the line, then m equal y minus y1 over, the slope m is equal to y minus y1 over x minus x1. Using algebra to rewrite gives the formula then, by multiplying both sides by x minus x1, the denominator, we'd get x minus x1 multiplied by m, flip around the equality, and we get this. This we call point-slope form. So why is point-slope form so useful? Well, if in practice it's basically all in the name. Given a point and a slope, we can always write an equation in N of actually a unique line which passes through the point and which has the desired slope. For example, let's try to find the slope-intercept form of the equation of the line that has a slope of 3 and pass through the point x, y equals 1 comma negative 2. Well, this is very straightforward. We know, so this is going to be my x1, y1, and we know y minus y1 equals m times x minus x1. That's point-slope form. That is, we can go ahead and just plug in now. So we have y minus negative 2, again, always be careful with the signs, x minus 1. So 3 was the slope, right? Now we just got to simplify down to get slope-intercept form. Simplifying down, we have y plus 2 equals 3x minus 3. And now we subtract 2 from both sides and get y equals 3x subtracting 2, so negative 5. This is now our answer because that is slope-intercept form. It has the form y equals mx plus b. Here b is negative 5 though, so it's minus 5. Now it's time for you to try an example. So try to find the slope-intercept forms of, find the slope-intercept forms of the equations of the following lines given the slope and passing through the given point. On the count of 3, I'll reveal the answers for these. 1, 2, 3. And there we have the answer. Note here that you need to get your hands dirty with a little bit of fractions. When you add 1 to both sides, you need to get a common denominator to get to 5/3. And over here, this is interesting because y equals 1 is just the horizontal line at when y is equal to 1. Well, this makes sense because our slope was 0. As a brief closing note, given 2 points, x1, y1, and x2, y2, we can always find the slope using them. Again, of course, see last video. Substituting this into point-slope form and using one of the points, we get that y minus y1 equals, substituting in the slope, y2 minus y1 over x2 minus x1 and x minus x1. This is called the 2-point form. So we've had several different forms, slope-intercept form, point-slope form, and now we also have the 2-point form as well. This form isn't used a ton, but it's still kind of neat to know you can just use it directly if you like having lots of formulas. For more practice in using point-slope form to write linear equations, be sure to see pages 31 and 32, numbers 3 and 43 through 64 of the textbook. And in our next video, we'll finish up with lines by talking about parallel and perpendicular lines.